Okay, so previous video, we went through how you could do simple linear regression in Excel. So now we're going to go and take one step further and look at multiple regression. We're going to be using the same data set we've been using before, and this is a simulated data set of credit card data that is 400 records of let's look at, you can see the data. It's got individuals' income, their credit limit, their credit rating, how many cards they have, how old they are, how many years of education, gender, are they a student, are they married, what their ethnicity is, what their balance is. And our goal is to try to predict what the credit card balance is. And this may be to look at a new customer and see what we should expect out of them. It may be a way of forming a baseline. So if we look at someone's balance and see, does it look out of line with what we'd expect given their characteristics? There may be fraud or something unusual taking place. There may be multiple reasons why we want to build this model. So that let's go and look at the where we started was with a very simple model where we looked at taking the variable that seemed to have the strongest pattern between the characteristics of the customer and their balance, and we built a very simple model, and this was using simple linear regression, and that we got this as being the output, and the output using regression. And we'll be going in, you looking at Excel as to how it's doing this when we get to the next stage. That it gives us output that describes three things. One is the performance of the model, and there the key thing that we typically look at is to what extent is the what's the overall performance. Many people like to look at the R square. That some like to look at the standard error. That tells us how accurately we can predict the credit card balance, and this says maybe within about $230, maybe more than that, maybe even twice what a standard error is. So that's not very accurate, $460. There's a table of stuff that's really, if you're getting to get into detailed statistical analysis, we'd need. And then there's the basic, what is the formula for the model, the coefficients. And previously I said there was an intercept plus a slope with the, and times rating. So this says the intercept is minus 390 plus 2.566 times the customer's rating. And that model ended up, here was the scatter. This was the customer's credit score, credit rating. Here was their balance, and the scatter went upward sloping. So higher credit score, higher rating. They seem to borrow more. We fit a straight line through that, and we've got an equation to that line. But when you look at it, if you were someone with a rating of around 500, which was an average customer, their balance is around $900, somewhere close to that. On average, that's what we get for a customer for the line. But you can see that the individual scatter is quite big. So if I was predicting for a particular customer, my best guess is 900, but maybe it's as low as 200, or maybe it's as high as 1,000 or 1,500. That's quite a big spread that I've got here. And can't we do better than that? So what we'd like to do is look at something that's more involved, something that includes additional variables. And that what we're going to do is go back and look at what other variables were correlated with balance. We had information on correlation. Oops, sorry. That was from a previous slide where we looked in Excel as to the correlation among the variables, and we're predicting balance. And the one with the strongest correlation was rating, okay, with 0.86. A correlation close to 1 is really good. And if we looked at other ones, there was a limit. was also very, very high. Income wasn't too bad. The others are pretty small. They're close to zero. So maybe I'd like to build a more involved model. I'm going to look at one that takes their rating and their limit. And this is a linear model, linear regression. So it's just a straight line relationship. So I've got an intercept, I've got a slope for rating, and now I've got a slope for limit. And then there's the noise that's left over that's scattered around this. So I can go and do that, and we'll just show quickly how that's done. So you go in here, go to data analysis, go down here to regression, okay? And it asks for a variety of things. Let me just take these guys out that I've had before. That first of all, it wants my y variable. What am I trying to predict? Well, I'm trying to predict the balance. So that's everything in this column here, the balance column. So all the way down here. Whoops, sorry, I goofed. Let me just type it in. It's in column L. I'm going from 1 to L401. Okay. Now, the x variables, they've got to be, go back up here, I want income and limit. So they're in columns B and C. So I'm going to go from B1 up to C401. So all of the income and limit stuff here. These two columns have got to be side by side. Excel doesn't like it if they're not. Now, in this case, they are. They're both together. I can't grab one column and then grab some other column. Excel will not be happy with that. And you'll also notice that there are no blanks in here. Excel and in general, with multiple regression, we can't do it if there are blanks. A blank isn't a zero. Our formulas need numbers in all of the boxes. And so if there are blanks there, you're going to have to take out those records or find some other way to try to adapt to it. And I'm going to put this in a new worksheet. I've got labels up here. I've got income, limit, and I use balance. I use the top row. And if I click OK, I get new results. Now, I'm not going to look at those plots and residuals at the moment. I forgot I had that checked off. But let me just look and see what I've created here. So, whoops, excuse me. So if you look at this, it's got now an R square of 0.87, and it's got, oops, sorry, this is income and limit. That's not what I wanted. I wanted rating and limit. Let me go back and do this again. So I wanted rating and limit. Let me go back to data analysis, regression, and I want columns C and D. And I'm going to skip these plots for the moment. Here I go. We'll look at those plots soon. They're useful to us. Oops, excuse me. So here's my results. That the R square is now 0.7459. Well, what did we have before? That when I had my simple model previously, it had 0.7458. And I'm now 0.7459. It's not changed. My standard error is now 232, and before it was 232. It's not changed at all. My intercept was minus 390 plus 2.566 times rating. What do I get now? I get minus 377, a little bit different. 2.2. Okay, this one's changed for rating, and I've got a very tiny number for limit. What's going on here? It's like limit isn't in there at all. If you look at your coefficient and look at its standard error, so look at, after you fit your model, moment I've got issues because my performance is not improved, even though the limit should be a useful variable. This is the coefficient. My best guess of the contribution of limit is 0.0245 times the credit limit, but it has a standard error of 0.06. As a rule, that we've got this thing called empirical rule we use for all kinds of things. And the empirical rule basically says, let me just, whoops, excuse me, make my text a little bigger for us to read. Empirical rule says that 2/3 of the time that you're between one standard error. That means that this is an estimate. Okay, these coefficients here are estimates. They're not exact. And so the slope is somewhere between 0.02, 0.02 minus 0.06 and 0.02 plus 0.06. I don't know if you can read that. Let me make this bigger if it can. No, it's not making the whole thing bigger. Excuse me. What's that? Well, that's make it bigger for us again. Between minus 0.04 and plus 0.0. So the slope could be going down, could be sloped downwards, could be sloped upwards, or it could be flat. It could be anything. Limit's not telling me anything. What's happened here? Because I thought limit was important. Well, that if I go and look at credit limit and credit rating, I see that as the credit limit goes up, the rating goes up, or the rating goes up, the credit limit goes up. They're what we'd say perfectly correlated. If I know the rating, I know the limit. If I know the limit, I know the rating. So adding the second variable to my model told me nothing I didn't know already. It's not helping me. It's not helping me at all. So let's go back. Let's go and pick something else. Let's try, and if we look back to this table, okay, these guys here, if you look at it, had a super high correlation between them. And that was why it's not giving me new information. So let's try balance, or try income and fit that model. So if I go back to my data and I'm going to pick income and rating, ooh, they're in different columns. It's not going to let me do this. If I go and try to do that, it's going to grab limit in between. I can't grab this column and that column separately without grabbing limit. Excel wants it as a block. So what I'm going to have to do is copy the two of these into a new sheet. So that's what I've already done. I copied income into one column, rating into another, balance into a third. So the variables have to be in adjacent rows because Excel grabs this thing as a block, grabs both together. And then I can go to data analysis. I can go to regression. I'm now going to pick the y variable is in column C, and my x variables are in columns A and B. I've got labels here. let me just put it into the same sheet, and I'll put it just over here to the left, put it E1, and get this box out of the way here. There we go. And now if you can see this, my R square has gone from about 0.745, 0.75 thereabouts. It's now 0.875, which is quite a big improvement. That's like the highest is going to be 1. So I've closed the gap by half. My standard error has gone from 232 to 162. So that's quite an improvement. And then here's my model. My model says, let me go back here and type this in so you can see it. It says my estimated balance equals minus 534, 8, and it's going to go minus 7.67 times income plus 3.95 times rating. And if you remember, the previous model was something to the effect of estimated balance is equal to what? Minus 390 plus 2.57 times rating. This is the line part of this. So my intercept has changed a lot. It's driven down from 390 down to 534. That, if you recall, the intercept is what would be the balance if your income was 0 and your rating was 0. Those people don't have credit cards. They don't make sense. My slope for rating was before 2.57. Now it's up to 3.95. So it's taken a big jump. Things have shifted around a lot. But look at this. Look at the value, the coefficient for income. It's negative. If you recall, the correlation was positive. That why is it negative? We had income, as it goes up, the balance goes up. Borrowing increases with income. We saw this happen before. But just like we had with rating and limit, as income goes up, your credit limit goes up. So it's not as strong a correlation as we saw between the limit and rating, but still it's this is really, really, really high. So what's happening here is that income and rating are correlated with each other. So income gives me some insight about rating, or rating gives me insight about income. And this complicates everything. I can't talk in that previous slide about changing someone's rating without talking about changing their income. Because if they have a higher rating, they probably have a higher income. Or I can't talk about changing their income without changing their rating. The two of them move together and they interact with each other. And that's why I'm getting this strange coefficient. This problem is known as multicollinearity. And it's fairly commonplace that you'll find that when you build your model, you'll end up with your variables interacting with each other. And it's very difficult then to separate out what's the effect of income from the effect of credit rating. From a prediction point of view, maybe I don't care. But if I wanted to do causal analysis and try to explain why some people borrow more than others, I'd like to be able to separate out these two factors. In this instance, I can't do it. So this is like we saw with rating and limit, but not quite as extreme, but it's still a problem. And that was the problem we had previously. This suggests building models, just throwing in variables is messy. And maybe we need to approach it differently. So adding multiple variables, adding variables to a model, that is there a better strategy? How do we decide? So what we could do is build our model incrementally. So before I had a chart that said, well, I put in rating and I didn't like the outcome. I had errors here. My predictions were high and low. These gaps here in predictions, the points not falling on the line, are known as residuals. They're the gap between the predicted value, the orange line, and what we actually saw. And sometimes the errors are very small, and sometimes they're very big. That I'd like to reduce these. So these are residuals. Maybe I can find a way of trying to explain why there are residuals. Explain why you're making mistakes. So look at your mistakes. What can you learn from them? And from there, what can I do better? Right? So how do I learn from that? If I did my initial regression, at which I got this sort of result here, I could have asked along the way to give me residuals. So back here, let me just show you what I should have done. Well, I did do here. When I did this, and I went to data analysis, did regression, and I picked a bunch of variables. They were in column C and da, da, da. Down here, down below, there are a variety of things I can ask for. Ask for residuals and residual plots. We can skip the other things, but there are a couple of checkboxes here. And if you do that, you will get the picture that I just had a minute ago. Where was it? So in the very first one, I could have gotten this as being the residuals. The first observation, the prediction was 335, and it turned out there was an error of minus 2.399. Yeah, it was pretty close. The next one, the prediction was 848, but I was off by 54. Next one, I predicted 928. I was off by 348, a big error. So some of them you'll see are big and some are small. And these are all the errors. And here's a plot of it. As the rating went up, what were the errors I was making? And you can see that there's some odd patterns here. I've got a downward sloping line here, the scatter a lot above and below. Why don't I go and try to predict the residuals? So let me take the residuals. I copied them into a new column, and I copied all the other variables over with it. And then I went and I looked at correlation. How can I predict these things? Which things seem to be related to my residuals? If you recall how to do that, you go to data analysis, you go up here to correlation, that you pick, okay, which columns do I want? I wanted A through H. And down from rows 1 to 401, my data's in columns, I had labels, and I put the results here in the table. So let's look at the table. And I am trying to predict now, not balance, I'm trying to predict the residuals, what's left. So if I look at income, after I've taken account of rating, income is negatively related to residuals. So as income goes up, the error becomes more and more negative. Rating or limit has no meaning whatsoever. What does 5.9e minus 16 mean? It means there's a lot of zeros here. Let me see if I can get it to give me all the zeros. No, won't it? Let me just see if I can. There, at least in terms of, let me show all the decimals. Oops, wrong way. There it is, 5.86. But all these zeros come in front of it. So when you're seeing what we had previously with a E minus something, that's scientific notation. Generally, if it's minus 16, it means it's zero. It's not um, in there. Credit cards has a low correlation. Age, negative, somewhat correlated. Education, and ignore balance. That's you always get a correlation between the predicted variable and its residuals. But my next best one would have been income to add. So I'll add income in, but now I recognize that I should expect it to have a negative relationship with that um, with that variable. Now, if I did it after putting in income, and I fit the model, okay, so this is when I added that in before. I could go and look at the residuals then to see what's left over. And you see there's scatter around. It's not quite as wild as it was before. My model is somewhat better, but now I get two plots. One is as income varies, how do the residuals vary? And I'd like them to be clustered around the zero line. And with rating, I'd like them to be more clustered here. And they are more clustered than they were previously. That here it went from like minus 800 to plus 800, and now it's going, more like minus 300 up to 500 or something. So it is closer than it was previously. And again, I get a whole bunch of residuals. So what I could do is go and grab these residuals, select them all, and copy them over into a new table with the other variables. So I've done that already. So I copied that over. I copied all the residuals here, and I copied all the other variables over, and then I did my correlation once again. And so this is what we get. So now when I'm looking here, my residuals here in this row, and with ID, I shouldn't have any. With income, it's this minus 16 again. It means it's no relationship. With limit, it's almost zero. With rating, it's zero. With cards, 0.01, it's pretty small. Age, I've got a little bit, minus 0.09. And education, I've got 0.04. Yeah, and then I get stuff with balance. So if I had to add a third one, maybe I'd add age. So I could go and do that a third time. So I've copied ID, or the income, the rating, the age, the balance, and I've tried fitting the model again. Now, the correlation was pretty weak, so shouldn't expect a big improvement. Before I was like 0.875. Look at it, I'm at 0.876. My standard error before was 162. Well, I think that was, um, let me just go back and see where I was here. Yeah, 0.875, standard error 162.88, and now it's a 162.38. Barely any change at all. That my coefficients, they change again a little bit from where they were. I've got that negative relationship with age because my correlation was negative. Seems to suggest the balance goes down by almost $1 for each year, but it's not really changing anything significantly. My residual plots I had here, just noisy stuff. So by the looks of things, that's as good as I can get. If I took the residuals here again and tried to find correlation against the other variables, I'm going to find I can't do any better. So at this stage, I might want to stop. And that's where we're going to stop for this video. And adding the variables that I've been working with, this is the spot to stop. That the because just treating these variables the way they are, adding them in isn't going to help me. I'm not going to get any better unless I rethink what I'm doing as a model. And that we'll look at next. But we're all done for now. So bye.